Hi, this is Bruno Adorno, and in this video, we're going to explain you the workflow and how we built the code in Google Earth Engine to calculate fractional vegetation cover. This project is hosted in github.com/badorno/fractional vegetation cover. As you scroll down, you can see a little bit about us, and also you can check the image of the workflow that we're going to explain a bit. And also how to install the code editor in case you're a first-time user, how to access the code editor. And if you're not knowledgeable about remote sensing fractional vegetation cover, I highly recommend you to watch this lecture as well, which provides you some concepts on fractional vegetation cover, why measure it, some ideas on remote sensing in urbanized areas. We'll define and show how to calculate this very popular normalized difference vegetation index, and also the fractional vegetation cover, which is our goal. Also, we'll compare the NDVI and fractional vegetation cover results. After you have watched this video, in case you need, you are able to understand a little bit more the workflow. In Google Earth Engine, we have a pre-processing phase in which we select Sentinel-2 1-year surface reflectance image collection, mainly in the RGB visible bands and near infrared. And after selecting this image, we clip it to the region of interest. We apply a function to mask cloud and shadow and select the median pixel to our final composite. This function to mask cloud and shadow is important because the clouds and shadows that appear in the image should be removed. Sentinel-2 has a product called SCL that brings some pre-classification of clouds and shadow and other features as well. So we use this to mask the cloud and shadow from our image, and then we work only with the pixels that are valid. After we have our composite, we calculate NDVI using the red and near infrared band. We use the visible or the false color composition to make interpretation of the satellite image. So we can find some dense vegetation area to sample our NDVI-S and some area with non-vegetation to sample our NDVI-O. With these samples, we're going to calculate the fractional vegetation cover and display some preliminary results in which our fractional vegetation cover will range from 90% to 100% in white to dark green. So the areas with 90% or below will be displayed in white, and you can select them in case they probably have 100% vegetation. The same happens to the non-vegetated area, in which the fractional vegetation cover is displayed between 0 and 1%. So the areas with 1% or more vegetation will be in white, and these pixels could be selected in case this is a non-vegetated area. So you rerun again the code, and we will have your refined result, and you may optionally sample new areas in order to refine even more your results if it's necessary. Okay, now let's go to the code. To go, you select this link in the repository in case you already have your code editor account. In case you don't have, please click on this link, which will describe you how to obtain your code editor account for your research. By accessing the repository, the code will open to you in the top left panel named FR Refined. It will be in the reader section. If you need to make some adjustments to edit this code, you can save it and create your own repository in Code Editor under your username. So you choose a repository name, for instance, FVC, and the file name you can just change or keep the same. So now in the owner section, you have the same code, but you can freely edit. So in this video, again, I'm just explaining the code. In the next one, we're going to move to this bottom panel, which will interact with Google Earth Engine environment. So To give more emphasis on the code, this code, as I mentioned, has a pre-processing phase in which we select an image collection of Sentinel-2 surface reflectance. You can read more about it if you copy and paste in this search tool over here. Okay, this is the one we used, the Harmonized Sentinel-2 MSI. If you click, you have the description of this data, the bands. As I mentioned, it brings the SCL band with some pre-classification of cloud shadows and areas of cloud with low, medium, high probability and cirrus. So this will be important for creating our function to mask clouds. And beyond that, for sure, we have the visible bands, blue, green, and red, and the near infrared. Other bands, such as shortwave infrared, can also be used for image visualization, but not for the purpose of calculating NDVI and fractional vegetation cover. The area of interest will be drawn by a polygon, as we will show in the next video. The cloud, this part here creates a cloud mask function using the SCL band. Then we also set up a user interface, so you can select the date range that you want to search your image. So for instance, I suggest to select 1 year of image. In this case, by default, we have August 2022 to August 2023. But you'll be able to change to other date range. This part here shows what happens when you click the submit button in the panel that we showed to you, which basically is the creation of your time composite image, which filters the collection within the date range that you chose, apply the cloud mask function throughout your image collection, select the median as a time composite metric, and click the image collection to the geometry. And also it rescaled the Sentinel-2 image to make sure it brings surface reflectance values between 0 and 1. And we create a false color composition in the RGB scheme using the shortwave infrared, near infrared, and the red band to help us interpret our image. Then we add the map for visualization, calculate the NDVI. Google Earth Engine brings us this function that allows us to calculate spectral index that has a function similar to NDVI, which is a difference between two bands over the sum of the same bands. For NDVI, we calculate the difference in sum between the near infrared and red. So they are chosen here. And then we select the name of our product as NDVI. We define a visualization scheme from dark blue to white and dark green, from -1 to 1. By adding RGB and NDVI maps, we'll be able to sample regions in dense forests to be our NDVIS. Then the code will take the minimum of the sampled pixels as NDVIS. For all pixels above it will also be a very dense vegetation. And do the same for NDVI-O. So from samples selected as NDVI-O, the maximum will be actually our NDVI-O. For all lower values will also be of non-vegetated areas. As we have NDVI-S and NDVI-O, we'll then calculate a normalized NDVI by subtracting from each pixel of NDVI the NDVI-O as non-veg, and dividing them by the difference between the NDVI-S and NDVI-O. Then we calculate the fractional vegetation cover, the FR, by elevating this normalized NDVI to 2. And in this part here is important because we have to do some manipulation of our results. As I mentioned, all values with NDVI above NDVI-S and below NDVI-O should have value of 1 and 0. And this is what happened here. So we modify the NDVI normalized and substitute in our result exactly those pixels above and below the thresholds. We will have a preliminary results in which we will have some visualization in white to dark green palettes between 0.9 and 1 to inspect dense vegetated areas, and between 0 and 1% from black to white to inspect non-vegetated areas. So this visualization will help us to select other pixels that could actually be our NDVI-S and NDVI-O. This will be better explained in the next video. Once you have the result refined enough, you'll be able to export to your drive either your samples or your images. Here, it's selected to export your RGB image, but I can choose to export my FR result, which was produced here, right? And which is our goal in this video. So as I put to export my FR result, I'll be able to save it in my Google Drive. In this code also, I let this line here to compare your result with an alternative fractional vegetation cover by selecting as NDVI-S 0.85 and as NDVI-O the number 0. This usually is the preference of some researchers when they want to make easier to select as 0 the minimum NDVI, or maybe just select the minimum NDVI in the same or in the maximum NDVI in the same as NDVI-O and NDVI-S. This maybe for making process more automatic, for analyzing multiple cities can be important, but it kind of disregard that in each city you should have a preferable thresholds for NDVI-S and NDVI-O. So in our next video, we'll be able to create our time composite to calculate NDVI, to calculate fractional vegetation cover by sampling interactively our NDVI-S, NDVI-O, and export our results, and also compare with NDVI to see the implications of using each product. Thank you, and see you in the next video.